Hello children, and welcome all of you to the class of science. From chapter number 11, work and energy, we have discussed about work done. We have also discussed about what is positive work, negative work and zero work done. At the same time, we have understood the concept of kinetic energy and potential energy and the derivation for kinetic as well as potential energy. In today's video lesson, we are going to discuss about the concept of power and going to understand the commercial unit and the higher unit of power. So here we go. Let's have a quick revision of what we have done in the previous classes of science about work and energy. We have discussed that energy is ability to do work, or it is also described as the capacity to do work. The amount of energy possessed by a body is the amount of work it can do when that energy is released. Alright, so when work is done, we say that it is a kind of energy. So I told you that work and energy are interrelated with each other, and that is the reason both work and energy has the same SI unit. Energy is a scalar quantity, and SI unit of energy or work is joule, and 1 kilojoule is equal to 1000 joule. This is the relation which you have to keep in mind. The main forms of energy are kinetic energy, potential energy, chemical energy, heat energy, light energy, sound energy, electrical energy and nuclear energy. We have also understood that mechanical energy is of two types, that is kinetic energy and potential energy. We have derived the expression for kinetic energy as half m into v square, whereas potential energy is given by the formula potential energy is equal to m into g into h, where h is the height at which the object is placed, g is acceleration due to gravity, and m is the mass of the object. Alright. Now let's understand some of the examples of potential as well as kinetic energy. So when you pull the catapult in this manner, when you stretch the strings of the catapult, it has potential energy. And the moment you leave this string, it moves, it goes ahead and it moves like this. So the potential energy stored in the string gets converted into kinetic energy. Have a look at the second example, and in the second example you can see a bullet and a gun. So before the bullet is fired from the gun, it is at rest. Alright, you can just see bullet is there inside the gun, and we know that energy which is present in an object which is at rest is the potential energy. So the bullet in the gun has potential energy. Alright, and as soon as the bullet are fired, when you press the trigger and the bullets are fired from the gun, the potential energy gets converted into kinetic energy. Have a look at the picture once again. You can observe that now after pressing the trigger, the bullets are coming out of the gun and the potential energy of the bullet is converted into kinetic energy. Let's have the example which is related with your day-to-day life. You all might have gone for swimming. So before diving into the water, what do the swimmers do? The swimmers always stand on the diving board, and when they stand on the diving board, they have some amount of potential energy because the swimmer is steady there. And as soon as they dive into the water, this potential energy is converted into kinetic energy. The moment you dive into the water, the potential energy gets converted into kinetic energy. So this is how you can relate your understanding of kinetic as well as potential energy into the examples of your day-to-day life, and that will make the concept very easy for you all. Moving to the next concept, this is transformation of energy. You all are aware that the conversion of energy from one form to another form is called as transformation of energy. And if I ask you about this, you can give me several examples of one form of energy getting converted into other form. So when this energy is converted from one form into another, the total energy always remains the same. And this is very important thing which was first put forward by James Pascal Joule, and he was the one who studied the nature of heat and discovered the relationship of heat with mechanical work. And this invention of relationship between heat and the mechanical work led to the law of conservation of energy. Children, you all will remember that the SI unit of energy is Joule, and this unit is given to honor the work of James Pascal Joule. He was the one who has done lot of study and research in the field of energy and work done. So law of conservation of energy states that the energy can neither be created nor destroyed, but it can be transferred from one form to another, and the total amount of energy always remains constant. This is very important thing to understand. What is the meaning of law of conservation of energy? This law states that energy can neither be created nor destroyed, but it can always converted from one form to another, and the total amount of energy always remains constant. Let us understand this with the help of one example. When I say total energy, it is the kinetic energy plus the potential energy of the object. So consider a ball falling freely from certain height. Alright, so have a look at this figure. A ball at certain height, let h be the height at which the ball is holded by the girl. Now ball is at certain height, and we all are aware that when the object is at certain height, it has only potential energy. So the potential energy of the ball is m into g into h. Now by the time it is about to hit the ground, the moment you leave this ball from certain height, its velocity changes, and therefore it has kinetic energy, that is half m into v square. So when you are holding the ball at certain height, it has potential energy, but when you leave the ball and it is about to hit the ground, it has potential energy. Therefore the energy gets transferred from potential energy to kinetic energy, while the total energy remains the same. So this is how law of conservation of energy we can understand. Alright, one form of energy getting converted into another form. With this, let's move ahead to the new topic. Before I reveal the name of the topic, I want all of you to pay attention to the example which I am explaining you. So we'll consider two children. Let A and B are the names of two children. Alright, and let's imagine that both of them, they have the same weight. Both start climbing up a rope separately. So this is A, this is B. Alright, two children, they have the same weight and both are climbing the rope. Both reach the height of 8 meter. So this is the height of 8 meter. Both reach to this particular height. A takes 15 seconds, alright, to reach to that particular height, whereas B takes 20 seconds to accomplish the task. Now what is the work done by each? Now you can just recollect the formula for work done. What is work done? W is equal to force into displacement. Now in our case the displacement is the same. It is 8 meter for both of them. So work done by them remains the same. The work done for, as I said, it will remain the same for both of them. But A has taken less time than B to complete the task. Isn't it? Because the displacement is same, work done by both of them remains the same. But A has completed his task earlier than B. So who has done more work in the given time? Say in 1 second. So can you answer this? Work done in the given time. Who has done, you can say, more work in 1 second? To explain this, to understand this, we will introduce the concept and which is called as power. So power is work done in unit time, or work done in the given time is power. It is also explained as the time of consuming, the time at which the energy is consumed, that is also called as power. Another definition, the time rate of doing work is called as power, and it is denoted by letter capital P. So like how I have explained you the definition, I can write it in terms of formula. Power is equal to work done upon time. Alright, so in the example which I told you, work done by both of them is same because the displacement is same. But since A has completed the work earlier than B, I can say that A has more power as compared to B. Alright. So I can write in terms of the letter which is used. P stands for power, W is work done, and T is the time. Then the second definition, work is also the energy consumed in given time. So we can write P is equal to E upon T. Now what will be the SI unit of power? So for that, let's first make this understanding clear that power is a scalar quantity and SI unit of power is watt. Now how does this unit describe? Just look over here. Power is work done upon time. Alright. The SI unit of work is joule, SI unit of time is second. So power is equal to joule per second. And this joule per second is given the name as watt. Alright, so power can be watt or joule per second. Now how will you describe this unit watt? 1 watt is the power when 1 joule of work is done in 1 second. So everywhere if you put 1, you can describe the unit of power. 1 watt is 1 joule of work done in 1 second. Alright. 1 watt is the power when 1 joule of energy is consumed in 1 second. So according to our second definition, that the amount of energy consumed in given time is also power. So 1 watt is the power when 1 joule of energy is consumed in 1 second. Then the bigger unit of power is kilowatt, and it is represented by kW. K for kilo, W for watt. Alright. When it is a higher unit, power is more, during that time we use the unit as kilowatt. And 1 kilowatt is equal to 1000 watt. This is the relationship between kilowatt and watt. Other than that, there are some other units to measure the power. That is megawatt. This is another higher unit. So 1 megawatt is equal to 10 raised to 6 watt. So when it is electrical energy, during that time you must have seen this unit as megawatt. How much power, electrical power in megawatt. So 1 megawatt is equal to 10 raised to 6 watt. There is one more unit which is called as horsepower, and this 1 horsepower is equal to 746 watt. Now this horsepower, or the power of engine of a car or the vehicle, is measured in terms of horsepower. So this water pumps or engine of a vehicle, how much power these engines they have, that is measured in terms of horsepower. And this unit of horsepower and getting converted into watt as 746 was first given by James Watt. And you're very well versed with the steam engine. The James Watt is much took the credit. We can just give the credit of steam engine to James Watt. So he was the one who gave this relationship between horsepower and watt. 1 horsepower is 746 watt. Alright. Then the commercial unit of energy. Commercial unit means on large scale in the industry when this electrical energy is used. That commercial unit of energy is kilowatt hour. Alright. And the unit kilowatt hour means 1 kilowatt of power supplied for 1 hour. So how much electrical energy is supplied to us for 1 hour, that is measured in kilowatt hour, which is called as the commercial unit of power. This is not mentioned in your textbook, but this is just for your extra information. 1 kilowatt hour I can write as 1 kilowatt into 1 hour. 1 kilowatt we can write as 1000 watt, and 1 hour is 3600 second. And if I can just count the number of zeros and give a decimal point after 3, I get 3.6 into 10 raised to 6 joules. So 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. Alright, so we have converted kilowatt hour into joules, and this 1 kilowatt hour is called as 1 unit. So when you get your electrical bill, and if you see it carefully, that is written there as how much amount of units we have consumed. So maybe 300 units or 100 units. So what is that unit? That 1 unit is 1 kilowatt hour. Meaning is that 1 kilowatt of electrical energy we have consumed in 1 hour. If it is 20 units, then how much amount of energy? It is 20 into kilowatt hour, that is 20 kilowatt hour. And in terms of SI unit, 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. This last part which I have explained you about 1 kilowatt hour is not there in our textbook, but this is definitely there for you in standard 10th, and it is always better to have extra information, because on your electrical bill you have always seen this units and kilowatt hour. So that 1 unit is equivalent to 1 kilowatt hour, which means 1 kilowatt of power in 1 hour. Alright children, so this is all about our lesson work and energy, a simple and short lesson and easy to understand. This lesson will be definitely there for our final examination, so start preparing for it, and in the next video lesson we will take the numericals based on the formula of work done, kinetic energy and potential energy. So see you all in the next video lesson. Until then, bye and take care.